I think the idea behind this was as the ARDC is coming together, and we're thinking about all the different services that are available, both technical services, but also sort of human services and advice, support, and that we have to offer. Thinking about, well, how can we provide that as a package to the partners we deal with? And to do that, we need, in the past, we've had an outreach team that has understood what services are on offer so they can take that message to partners. We have a skills team that understands what services we have to offer and how that fits in with the other services that are there, and how they can best, when they deliver training, refer to the services that are out there. We also have a technical team that provides data services, for example. So there's a whole range of different groups, different teams within the ARDC that reach out to partners and talk to partners in different places, in different points in time. And for them, it's useful to know what services we have to offer, what those services look like, how they are operated, just have a better understanding. So we said, for that, it will probably be good to do a series of updates about the different services that are out there that have been funded in the past, that have been set up by ANZ, RDS and Nectar in the past, and to share a bit of information at least about the current situation. Now, some of the arrangements might change a little bit, but we first, as a starting point, we said, well, let's focus this at least on the current arrangements around some of the services, and in this case, we decided to pick off the Nectar Cloud, Research Cloud. So we thought that would be a good starting point as a service that a number of you have already received probably questions about, or are starting to wonder about, and thinking, well, okay, how does that work? How is the Nectar Research Cloud operated? And what are the ins and outs and the different backgrounds that are useful to know when we go to our partners and talk to them about what services we have to offer. So this is intended just mainly as a presentation by Paul about Nectar Cloud, a bit of history, a bit of background, how it works, and from Joe about the help desk and how the support is arranged around the Nectar Cloud. And there should be plenty of time for questions and discussion at the end. This is very much focused around the current arrangements. It's less focused around what it will look like into the future, because that's something that still needs teasing out a bit further. But we thought this would be a good starting point for discussion. Not everybody was able to make it, so this session is going to be recorded, and afterwards it will be sent to those that weren't able to make it, so they can watch the video and get a bit of sense of what's discussed. The video won't be public because there'll probably be questions in here which are slightly more complicated or slightly more sensitive, especially around our relationships to nodes and partners in this space. So just to keep that in mind. But you can ask any questions you want to. This is internal, so feel free to ask any curly questions. So Paul, I hand over to you if you'd like to take it away.
Yep, thanks Keith. So I'll share, this is going to be a tag team presentation, so I'll start and then hand over to Joe. I'll share my screen. Yeah, let's see. All right, if that worked, you should see a slide saying Nectar Cloud. Is that okay?
Yeah.
Right. So in the Nectar program, my role back then was one of the two deputy directors. So Michelle Barker was responsible for the Virtual Labs program, and I was responsible for the Research Cloud. And Joe was the user support manager for the Nectar Cloud, and Wilfred is the operations manager. So Wilfred and Joe's roles are the same. Mine is kind of the same, but I've got a new title. So we'll get started. So the Nectar program started in, I think originally in 2010, but it didn't really get underway until about 2011. As I said, it had the two programs, the Virtual Labs and the Research Cloud. So I'm just going to focus on the Research Cloud today. It took a while of sort of planning organisation. So the cloud was actually up in production in early 2012 at a single node at University of Melbourne, and then expanded from there. So the basic idea behind the Nectar program in general was really just to enhance, it was an NCRIS funded program. It was aimed to provide computing infrastructure and also sort of computing platforms to help enable researchers to do, to use IT for their research in a better way than they had before. So really to try to provide the underlying infrastructure, both software and hardware, for people to do interesting, digital, data-intensive kind of research, to try to bring together, to more easily provide a platform to more easily bring together compute, data, software, tools, and so on. So one of the main things around Nectar, I should say, so the Nectar acronym is the National eResearch Collaborative Tools and Resources Program. So a lot of it was around collaboration and tools and compute infrastructure to enable collaboration. So the cloud was sort of, the whole concept of cloud was still in its early days back then in 2011. There was no, the Amazon cloud and some of the commercial clouds had started, but there was no local infrastructure in Australia for those international clouds like there is now. And it was still early days in terms of how people were using the cloud. But this was seen to be an interesting approach to enable researchers to provide, to get access to compute infrastructure that made it easy for them to collaborate across institutions. Right? So they weren't limited by institutional firewalls, by having to get people from another institution to get an account on their local system if they were from another institution. So all those things that can be quite complicated. And the other thing is to provide it in a sort of self-serve, on-demand way. So the Nectar Cloud is what we like to call infrastructure as a service. So it's self-service. So a researcher can just go in there and fire up a VM essentially on demand and start doing whatever they like with it. So it's not a managed service where they have to go to their IT staff and tell them they want something, and then eventually they might get it, and then every time they want some software installed or something else done or additional resource, or please add this person so they can access my resource as well, they don't have to go through all IT staff to do that. They can do this all themselves. Now, of course, some people don't want to do it themselves or don't have the nous to do it themselves in terms of support. So you can have a managed service. There's no reason why a node or an institution can't provide a managed service on top of the Nectar Cloud and do that for people. But predominantly we're looking at groups that just have someone who can do it themselves for themselves or for their research group. So just before we move on, talk about it very much. So it's been very successful. So I think probably more successful than was initially anticipated. So we've had a huge uptake. Lots of interesting groups that are using the cloud to do lots of interesting things. So here's just a brief example of a few. And note that these are, the cloud's used a lot by the big virtual lab projects, but these are 3 large projects that aren't virtual labs. So we haven't funded the development of any of this infrastructure that's run on the cloud. These are groups that have done that essentially themselves with almost no help from us. They just get on and use the, the resources. So one is a ARC Centre of Excellence in Plant Energy Biology based in predominantly in WA, but there's other groups they collaborate with around the country. So they've been using it to host databases, to run computing, compute servers and so on. The Cancer Therapeutics CRC runs most of its IT analysis on the cloud. So this group is interesting because they have potentially the largest industry collaboration ever in Australia in terms of the amount of money that they may end up getting, depending on how well their stuff works in terms of clinical trials and so on. But they have arranged with pharmaceutical companies that could be worth hundreds of millions of dollars. This is all done Nectar Cloud. And STEMformatics around STEM, which is essentially a virtual lab for stem cell research. Roland Mossbergen, who some of you may know, was one of the main people who set this up and used it. So that's got a big user community as well. So this is just a few examples of the over 2,500 projects that we have running on the Nectar Cloud. So just the architecture in terms of the cloud it was set up, it's said here it's a world first, which is probably true. We think it was the first in the world to be a federated research cloud across multiple research organisations. So it was originally set up as a partnership of 8 nodes, including the Pawsey Centre. There was an open call for nodes, as there was for the related RDSI storage project. The idea was that the cloud node should try to be co-located with the RDSI storage nodes to provide, fast, easy access to the data sets, and so the compute and data was essentially co-located. And for the most part, that was the case, that the RDSI nodes and the Nectar nodes were the same. There is a tension in terms of where the nodes are located between, wanting a small number of very large nodes that serve the whole country potentially versus, a node at every university potentially. So the view was we wanted some economies of scale, but not necessarily something that was just located at a single site or a couple of sites. That made it a bit more difficult to leverage co-investment from institutions, and also, added other complexities around not having infrastructure located at institutions where the big generators of data, like large scientific instruments, were, or just generally having groups wanting to have stuff that's locally actually hosted locally. So there was 8 nodes, and most of these nodes were already existing in terms of regional or local centres that provides e-research support for their members. The other interesting thing was they essentially covered all the universities in Australia. There's a couple of exceptions, but for the most part, these nodes or their members covered all the universities in Australia, which is one of the things we were trying to do. Now, Pawsey sort of dropped out of the Nectar cloud last year, so they decided they're still running an OpenStack cloud like the Nectar cloud, but they've decided they wanted to focus it as an internal cloud that's more tightly coupled with the Pawsey high performance computing systems and large scale storage that they have there. Now, NCI has done a similar thing. They have their cloud split in 2, essentially. They have one node of it, or one part of it, that is just like the Pawsey node, is tightly coupled to their HPC and large-scale data systems, and is a managed service. So it's not, a user can't just log in and fire stuff up. It has to be set up for them. They have root access to the VMs, for example. But then they have another part of their cloud node, which is just the more standard Nectar kind of node, infrastructure as a service that's run as part of this federation. So all of these nodes, they came on board sort of gradually over the first few years of the cloud program. So there was a couple of different phases. So Melbourne had the first node up and running, and then gradually some of the others came on board to add capacity and resources. So the Cloud Federation is based on OpenStack. So essentially, it's based on what's the buzzword these days tends to be open infrastructure. So open source software, not just at the cloud software layer, but sort of all the things underneath around Linux operating system, virtualization, hypervisors, container systems, container orchestration systems, etc. So all this stuff is all standard open source software. When it was decided, so we Nectar had a sort of technical consultation around what it should do, and so it wasn't Nectar that made the decision about OpenStack. It was this committee of a number of different groups that got together and tried to figure out what we should do. They ended up deciding on OpenStack, which was a somewhat courageous decision at the time because, as I said, the cloud was very immature. OpenStack was very immature software. But as it turned out, it was a very good decision, because if you were going to do that today, that would, OpenStack would almost certainly be your, the system that you would choose. It's by far the most popular open source cloud software. Has many thousands of commercial users, including some of the biggest companies in the world. Some of the OpenStack summits that they hold every 6 months are interesting. So I've been to a couple of those, and there's very interesting presentations by a lot of big companies. Tencent runs WeChat, which is a Chinese social media and marketplace sort of application that has 1 billion users, and that's all run on OpenStack. It's become the sort of technology of choice for telcos these days for various reasons, because it provides interesting a networking, sort of software-defined networking capability, and also allows you to deploy systems at any scale. So telcos often just want to deploy very small systems for local users, and they can do that very easily with OpenStack, or very large infrastructure. So as I said at the time, it was probably the earliest sort of cloud for research, or at least the earliest federated one. But now there's a lot of similar large-scale clouds running OpenStack in the world. So CERN's probably the most interesting one. It has the largest OpenStack cloud of over 190,000 cores. So this is significant, huge scale. I was at a presentation they gave, and they were showing some of the usage charts of the usage and how it went up and down and so on in their cloud. Their spare capacity at some points was larger than the whole Nectar cloud capacity. So they're operating a somewhat different scale. Now we often hear from people, oh, well, it's public cloud. Why don't Amazon, Google? There's plenty of commercial clouds. Why don't you just go and use those? Why do you need to run your own cloud? So it's essentially the same reason as why eBay, PayPal, Walmart, etc. all want to run their own clouds. There's a couple of different reasons. So one of which it allows you to run infrastructure on premise, so local infrastructure using your local network and connected to your local instruments or whatever systems that are generating the data. So in some cases that's a better option for technical and other reasons. I don't know that there's any universities that I'm aware of that are suddenly going to decide they're not going to run any local computing infrastructure anytime soon. They may be using the public cloud, but not for everything. And the other thing is it's actually more cost effective at scale. So if you have fairly small requirements, it's more cost effective to do things in the Amazon cloud, for example, than doing it yourself. But once you get to a reasonable scale, it's actually cheaper to do it yourself. The other thing, as I said, is edge computing. So OpenStack makes it easy if you want to, not just to deploy large-scale deployments, but also if you just want something small, you may just want a small amount of computing local to an instrument, a scientific instrument or something like that, and you can easily just roll that out with OpenStack. And of course, it's all open source, so it's all customizable, and it's a bit more of an innovation platform than a proprietary system that somewhat locks you in. So the way we run the federation is we use an OpenStack system called cells that allows you to essentially run different cells or different components of the cloud that can hook together in a federation to look like a sort of seamless, uniform cloud. So we have these 7 nodes that Nectar has funded, and ARDC continues to fund to operate the national infrastructure. But we also have other institutions that just have said, well, we want to run something like this at our own university or whatever with our own money. We want to run some virtualization system, and we just think it's worthwhile if we're going to do it to hook it into this national standard resource. So we use the same. They can leverage off some of our components of the infrastructure, so we don't have particularly core services, so they don't have to do it themselves. So they're saving some money there. But also, it just means for the end users and the researchers, they can use a system that looks the same as the national clouds, the same interface and so on, so it's easy to do. Now, users can log into the cloud, and Joe will give you a demo of this later, and they can actually ask for a particular node. I want to fire up a VM on this particular node, access storage at this particular node, or they can just say, fire me up a VM, I don't care where it is, and it'll just go wherever there's the most free capacity. So we have some centralized services that essentially just core services runs. There only needs to be one of these things, and it gets run centrally by core services. So that includes the web dashboard, the cloud dashboard that people log into and manage the API access, the authentication. We use AAF for authentication for people to log in using their AAF credentials. The virtual machine images that people can save and reuse and share. So all that's run centrally, but then at each of the nodes, they run the distributed federated services. So they they all run some compute servers. So the nodes actually run all the compute servers in the cloud. They run the cloud storage. There's two types of storage, what we call volume storage, which is only accessible at that local site, at that local node, or object storage, which you can access from anywhere and not just in the cloud. It's just you can access it via URL. It's just HTTP basically. And then we also, of course, run the user support and help desk and all that sort of stuff, which is coordinated centrally by Joe, but actually is done collaboratively across the nodes. So as well as running the standard OpenStack, we also run a bunch of the what OpenStack calls projects, which are essentially additional functionality that can run on top of OpenStack, but it's a sort of bit higher levels of service. So that includes things like data processing services, which run things like Hadoop and Apache Spark and so on for sort of big data analysis, database services. So the stuff like Trove, Sahara, that's the name of the OpenStack project that essentially implements these things on OpenStack. Then we have some application services like Heat is an orchestration service, so you can sort of automate the deployment and orchestration of your applications on different VMs. Murano is like an application store of packages that people have pre-written and you can just use. Magnum's a container orchestration thing that supports Kubernetes and Docker Swarm and so on top of OpenStack. Then there's advanced networking and a few other things. I guess it's also worth pointing out that, although this is a national cloud service, as I've said, institutions can add their own resources to this if they want to. So we have conceptually the concept of sort of nationally and locally funded resources and therefore national and local resource allocation. So we can allocate a sort of quota for a project based on a national one, which essentially means you can use the cloud at any of the nodes, or a local one, which just means you can if Swinburne, for example, is adding some compute resource to the cloud, then it's only Swinburne researchers who can use that. Or if Uni Melbourne kicks in their own additional money to provide some additional resources, then it's really just for Uni Melbourne people to use that. In some cases, some nodes have specialized. So we have a bunch of standard what we call flavors or instance configurations of different sizes that you can run anywhere in the cloud, but some nodes might have their own specialized ones that only work on their node. So they may have special things with GPUs, for example, or very large memory or something like that. And also, anyone can create their own virtual machine image that they or anyone they share it with can use. You can have private images that only certain people in your group can use, or you can have public images, some of which are the Nectar official ones, but some of them are just what we call community contributed images. So anyone can create an image and make it public if they want to, so lots of other people can use it that might have all the software, etc., that a particular research area or someone working in a particular research area might need. So as I said, it's been very successful. We've had pretty much, linear growth, at least in terms of number of users since it started. So you'll see the top graph is the number of users, which are now we've had over 13,000 people just logging into the Nectar Cloud and registering as a user. Doesn't necessarily mean they all use it. They might just done a training course or just kick the tires for a bit and then not really used it much afterwards. But many of them do. So we've, last year we've had over 4,000 different users firing up VM in the cloud. At any given time, there's about 2,000 users running virtual machines. Now that doesn't mean there's only 2,000 users of the cloud, because that just means there's 2,000 people who have fired up a virtual machine. Now there may be several people in a particular research group that are logging into that virtual machine and running analysis jobs or doing whatever. That virtual machine might be hosting a service like a virtual lab or something that may have thousands of users using it. So it's very hard to figure out exactly how many users are using the cloud, but even from the things we can easily measure, there are thousands of users, and we believe there's probably tens of thousands of users making use of the virtual machines or the services running in the cloud. We're still getting a couple of hundred new registered users every month. We have over 2,500 project allocations. 700 of those are across multiple institutions. So we're again supporting the collaboration aspect of this, trying to support projects that require multi-institutional collaboration. And over 300 of them are supporting projects with, like ARC or NH and MRC national research grants. So the bottom graph you can see here is showing the number of cores that are being used and the different colours of the different nodes coming on board. So the bottom one is the Uni of Melbourne, then I think it was Monash, and then I think NCI, QCIF, NCI, URSA, and so on. So over time, more nodes came on board, more cores and resources were available, which pretty much matched fairly well the increase in usage and demand. But as of about almost 2 years ago, probably about 2 years ago, essentially there hasn't been much resource. There's no additional funding for additional resources. So things flatlined for a while and even decreased when Pawsey pulled out and some of the older equipment was decommissioned. So there has been some nodes paying for their own additional resource to add to it, but it's pretty much just enough to keep it the same. So with our new capital, we're hoping to increase the resource significantly, which will be good. So this is just pointing out that we do track when people ask for a project allocation what field of research codes they're looking at. So we actually have resource allocations across all of the 22 top-level field of research codes, but as you might expect, some of the main ones that we support are in biological sciences and genomics, in sort of more computing areas, and maths, science, engineering, medical and health, reasonably large, and so on. Okay, so I'm handing over here to Joe, so I'll stop sharing my screen and pass it to Joe. While we're waiting for Joe to start, is there any questions on the stuff that I've just been going over?
I've got a question. Paul, you said that there's an AAF authentication.
I can't hear you very well.
Better?
Yep.
Sorry. You said there's an AAF authentication layer. How does that work when collaborating with industry?
So the way we do it at the moment is the way you do anything with AAF, where you're collaborating with someone that doesn't have a AAF account. Actually, there's a couple of ways. So one of which you can get them to have a AAF account. If your institution just gives them a sort of guest account or something, then they kind of immediately have a AAF account and away they go. So that's done for a lot of things. But the other thing is, having an account really just lets you log in and look at the dashboard and fire up a virtual machine. So if, for example, you just wanted to log into a VM, you don't have to fire it up. So if you're collaborating with someone, if you're in industry and you're collaborating with someone who's at an institution that has a AAF account, they can go in and start up a machine, and you can just log into it with SSH, right? You don't need a AAF account to do that. So there's a couple of ways around it.
And I guess the other one is the project criteria. Does it have to be a research project, or could you open it up to government?
Because we're funded by NCRIS, we're supposed to be supporting research. Now, that doesn't necessarily mean it has to be academic research. There's no reason why it couldn't be research projects happening in the government sector, potentially research projects happening in industry, but then we'd have to charge commercial rates, and given that there's commercial clouds available, there's no reason why they wouldn't just use that. But yeah, in principle, government research projects could potentially be something that we could support. But at the moment, most of that work with government and industry is essentially collaborations between people in the university sector with people in government or industry through LEAF grants, etc. Sorry, linkage grants.
Thanks.
Okay, well, I might continue with the presentation then, if there aren't any further questions for Paul. You can ask questions at the end as well. So the research cloud is operated by the 7 node operators, and we basically split it up into 3 teams. So we have core services that run the it's a team of technical staff that implement and operate the central cloud services for the Nectar Research Cloud, and they coordinate the federated cloud operations. And then the node operators run the nodes that look after the compute and the storage at the nodes. And then we have the user support team that we look after the help desk and the tier 0 and the training. So it's quite a lean team, supporting 13,000 plus registered users, approximately 16 full-time FTE. So in the core services team, it's made up of the National Operations Manager, who is Wilfred, and then we've got 6 full-time full-time staff working in core services, give or take. And then we also, well, we did have a few at the nodes, and we're just about to advertise, appoint some more staff as well there. The user support team, though, is quite lean. There's myself, the manager, and I'm full-time. And then the distributed help desk is funds 1.4 full-time person, but it's spread across about 20 staff in the nodes, as that's operated on a rostered system. So I'll explain it a bit further. And then we have a couple of part-time technical writers that write the user support documentation. So the Nectar Cloud dashboard is where users access the Nectar Cloud, and that's the address. I might just give a little demo. You can log in using AAF, and also for our New Zealand researchers, we've implemented Turakiri, which is equivalent of AAF. So I'm just going to log in. A bit of time, and I'm a Griffith staff member, so I'm logging in with my Griffith login. And every user, once they log in, they're allocated a project trial, so they can go and trial using the Nectar Cloud. And they're allocated to virtual CPUs for 3 months. So they can use one of those for 6 months, or they can use both of those in a 3-month period. And once they've finished using their project trial, or before, they can apply for a project allocation. And they do that through submitting an allocation request form. So just going into allocations, a new request, and completing this form, where they will say, you know, the time they need it for, the amount of resources they need, what actual resources they need. So some of those they have to specify the node. Some are provided across the federation. They need to put in a use case. So there's 2 types of allocation requests, I guess. You can pick unassigned, which means you don't care where it runs, can run anywhere across the Nectar Cloud, or they can choose one of the nodes. So the way allocation requests are approved, they're approved by allocation approvers at the node, or myself, or Paul, or Wilfred. And if they apply, if they choose, usually the allocation approver will see that it's a request from someone from who's their member by the domain name of their email, and they'll go in and have a look at that allocation. And if they think it meets the criteria, and they have the resources available, and what they're asking for is reasonable, they will approve it, or they will decline and ask for further information, or they will decline it. But for those unassigned ones, where it might be an allocation that's not tied to one of the nodes, like a University of Western Australia, for example, because they don't have a local node, they need to apply for a national allocation. And so we have criteria based on our national allocation scheme policy, and basically they need to have a Australian Research Competitive Grant to qualify for a national allocation, and then it's also subject to capacity as well. So if they're asking for volume storage, we actually have to get a local note to approve that, because that's run at a local note. So yeah, they submit an allocation request form by filling in all these details. Some of these fields are mandatory, and those are marked by the star. There's also help information in the question marks here that provides them with advice for what they need to add in those fields. And there's also a link to further information about meeting the criteria here. So, and why we're asking for grant information, which we've recently made mandatory. Some allocation requests, they may not actually have a grant, and they can click this button, I don't have grants, and then it will be up to the local allocation to assess whether it's a allocation request they want to support. I'm not going to do too much of a demonstration of the dashboard. This is basically where they manage the allocations in here. Applications is the Murano catalogue of applications. You can see there's 18 different applications we have available that people can install on their allocation, and that's always growing, which makes it quite easy to deploy things and get things up and running. From here, or users can log a support ticket by clicking on here, and that gets logged into the service help desk, which I'll show later how that works. And then they can also access our I've logged in, sorry, it should have just gone to the customer portal there, and actually access our Tier 0 support, user support site, which has lots of stuff on there. So I'm just going to go back to the slides. So that's really a very quick tour of the dashboard. Everyone can sign up. You can sign up and you can log in and get a project trial if you like, and try it out. You'll have AAF access, so feel free to go in and try that out.
Actually, it's probably worth mentioning that one of the reasons I think that the cloud has had such good uptake is we made the decision to let people log in with their AAF accounts. So they don't have to set up a special Nectar account or anything. They just log in and they automatically have a Nectar account. And we gave them these personal trials. So pretty much anyone with a AAF account can just log in and immediately start using the Nectar cloud just with a very small resource allocation. So I think that's been very beneficial to get lots of people on board and trying it out and seeing if it's something they want to use, and then they can apply for a bigger allocation.
Yeah. So as I said before, as we just said, the user logs in with the AAF credentials and they agree to the terms of use on initial login. There's links in this, and you'll be provided with these slides after the presentation, so you can access these documents if you want to review those and understand terms of use, or our Research Cloud National Allocation Scheme, which outlines, it's basically a policy about who can have an allocation and how that all works. And it also takes 2 to 3 weeks, usually, for allocation requests to be assessed and either approved or declined. I think I've covered most of the stuff in that slide. So this is our user support portal. So I'll just go into that. And I'll go back to the portal. So that's just the behind the scenes where the help desk staff log into. So this is our support portal. The address is support.ehelp.edu.au. It is linked from the dashboard. So this is where users can go to access our knowledge base, which has lots of support documents. My network's quite slow today, I don't know why, it's not usually. About how to use the cloud and so there's a lot like about getting an account, launching virtual machines. We've tried to make it quite easy to navigate, but if they can't find what they're looking for, there is a search bar here and they can search the site. We also have different forums available to communicate things to our users, such as we have a community discussion forum, we have a training forum, announcements, which we use, and known issues. So if we know there's an issue, we'll post it in this forum, and then we'll put it in our Twitter channel as well. And if it's something big, then we might email our users to let them know about it. But you can keep up to date by going and having a look at those forums. And different announcements. So when we launch new services, we'll put something in there and then do other communication as well. Service disruptions and things like that, we communicate there. We also have some, there is online training, but we don't actually provide training. The nodes do that, and this page here has the links to the different training that is offered at the nodes. It's something that we hope to improve in the future, but in the past it's been done by the nodes. We do have self-paced training, which is here through the training.nectar.org.au site. And it's self-paced training for users and also resources for trainers there. And it's a combination of videos and self-paced slide tutorial type media, training material. What else? So that's a quick overview of the support site. So if users want to get help, they can call our, there's a few ways they can do that. So the help desk is operated from 7 to 6 Australian Eastern Daylight Saving Time. And the first shift is done by University of Auckland from 7 to 9. That's their way of contributing to the help desk. And then from 9 till 6 p.m, it's staffed by staff at the nodes. So there's 2 shifts a day for the node staff. One starts at 9 and it goes to 1:30, and then the next one starts at 1:30 and goes to 6. So users can contact the help desk by sending an email to support@ehelp.edu.au or phoning 1300 080 431. We also have live chat available from our support site, which is, it just comes up down the bottom as a little pop-up chat, which you can talk to the help desk if you want to get a quick response. And if for some reason that chat isn't answered, it gets logged as a support ticket. So we also have service level agreement targets. So our goal is to respond to all tickets within 2 hours and resolve within 8 hours of being logged. And if the help desk can't resolve it within 8 hours, it then gets passed on to Tier 2 support. And Tier 2 support is by the nodes or core services, but usually we know pretty quickly and it is passed on within a couple of hours. There's some things that the help desk actually can't resolve and they rely on the nodes to do, all core services. So the 5 nodes, 5 of the nodes participate in staffing the disputer help desk, and they're TPAC, Intersect, University of Melbourne, Monash, QSIF, and then we also have Auckland that contributes to that morning shift. So I talked about the training, and you can get the links from the support site to those. That's about it for me. Paul, did you want to talk about the last slide?
Yeah, as Keith said, I just mostly want to talk about what we're doing at the moment, but just briefly saying that, you know, we are aiming to improve and change how things are done in the cloud. So the roadmap specified, you know, there was an increased need for e-research infrastructure and cloud computing. It also said we should be aligning more with international developments like the European Open Science Cloud. So we're working towards that sort of thing. But the main thing, I guess, that's been a problem for us over the past few years is just the lack of long-term certainty and sustainability, and the lack of capital funding to renew infrastructure. So that caused, and you know, problems with the nodes, problems with researchers and large research groups and increase areas, you know, being concerned about whether they can rely on the cloud and storage that we provided, given that there wasn't any long-term certainty and we didn't have funding to refresh, you know, old equipment and so on. So both of those key problems have now been essentially fixed. We have a large amount of capital funding available. We have long-term certainty around the services running, or an ARDC running for a while now. So we can address those problems, and the capital planning for, or the funding for how the capital should be spent is starting, but we still got a fair way to go to decide what happens there. We should just point out that it's not necessarily the case that we'll just be refunding the same nodes. There will certainly be a review of where the national funded resources will be. It doesn't have to be at the same nodes. It could be less. It could be more. It could be different. And we also have to deal with the growing demand that we have for organisations, universities, and so on that want to plug their own resources into the national cloud. And how do we deal with that in a sustainable way? It was always the idea was always that the Nectar would start out as the Nectar Cloud would start out as a low-level infrastructure as a service cloud, but that we'd work on trying to develop additional tools and resources and platforms a bit more up the stack, which would help it make it easier for researchers to use, for example, if they weren't so IT savvy. So we've done that to some extent, but and the virtual labs are perhaps the main way that we've done that. But there's certainly a view that we should try to make it easier for people to, for example, just fire up a Jupyter notebook on a cloud resource, hook in the data sets they want to access, and away they go, sort of thing. So that's something we'd really like to work on more in the future. And of course, as I said, there's good reasons for why you might want to not use the public cloud for everything and have some local resources. But there's also, no reason why you wouldn't want to take advantage of the public cloud now that it's there. But we just have to figure out what makes sense in order to do that. People can go and use the public cloud now, right? They can get the checkbook out and away they go, and we're not stopping them doing that. So it's more, what's the value add for us? What's our role in helping researchers to use public cloud and making it perhaps more interoperable with the Nectar Cloud? Some of the things we could potentially do. So anyway, just to point out, there's a number of future things we could do, but one of the things we are doing at the moment is just carrying on running the cloud as it is at the moment, and planning for how we would refresh it, the infrastructure, with the money that we have from the latest NRIP announcement from the government, which is quite significant. It's about $70 million for the next 5 years. Not necessarily all going to the cloud, but a large chunk of it was aimed to go to the cloud. So I think I'll stop there and just ask questions. I should point out, as Keith shared with you, we've written a sort of overview of the cloud document to help everyone to understand the cloud, I guess, a bit better, but particularly aimed at this group here. It's meant to be a sort of overview with pointers at more information and more documents with some more detailed information. And we've also had a crack at answering the questions that you asked. So if there were any questions around clarifying some of those answers or anything else we've talked about today, we're happy to answer those now or talk offline.
Okay, thanks, Paul. We've only got 5 minutes left. What sort of questions are there? Has anybody got any questions?
I have one question. Cloud Store has some services where they integrate from their storage system back to institutional systems. So, for instance, if you store research data in Cloud Store, you can create a description record and it pushes it back to the institution so the institution knows about it. Has there been any thinking about a kind of, what happens at the end of a project, so that either like archiving the work or connecting like an export function back to an institution and say this is the work that we've done, or like archiving the snapshotting the machine and putting it into kind of preservation storage, and kind of closing the loop. So I understand that the setting it up, but I don't really understand the kind of closing it down and archiving process.
Yeah, so as I said, we're really just offering low-level infrastructure here. It's up to the researchers to do pretty much everything, right? If they want to archive stuff, if they want to back up stuff, if they want to move stuff somewhere else, that's up to them. We don't have any particular approach or standard way we say people to do this. I mean, I think that's something we should be doing more. So there's definitely, there's no reason why people can't, at the end of the project, snapshot their virtual machines and stick them anywhere they like, right? They can stick them in Binder Hub, they could stick them in GitHub, they could stick them in their own local repository, they could do whatever they like with them. Any snapshots just on Nectar object storage, so they can easily move that anywhere else. Or they can just leave it there and essentially it gets archived on our Nectar object storage. But certainly there's been, we've had some discussions around how could we make things easier for researchers to save their, what they're doing. One thing is how could we make it easy for people to mount their cloud storage on a Nectar virtual machine. So that's something we worked a little bit with ARNet on, but it's a bit problematic. There's also been discussion around, should we host an instance of Binder Hub for Australian researchers here, so people can have, containers or images or whatever for all their, here's all the research work I've done, I've stuck it in a container, and I just want to archive it somewhere so people can access it. In principle, people could do that with some of the, international services, but it'd be an interesting thing for us to provide here. I've stored my research in a container, and if someone wants to fire up that container and run what I've done and play around with it, they can do that easily and they can run it on the Nectar cloud. I mean, that would be potentially an interesting thing.
So basically, I think, Paul, we were looking at perhaps providing some more services that complement our infrastructure as a service type service. So one of them might be a backup as a service, etc. But we won't, it's very unlikely we will be prescriptive about how they would do that, or if indeed they need to use it, because it's, people have different needs. But also once you start being very prescriptive about these things, it starts becoming more, the barrier to entry, I think, it starts to rise. So.
So just thinking on that, as we're talking about trusted research outputs and being able to create replicable research, you maybe not being prescriptive, but maybe being maybe providing some guidance and saying, well, one way you can make sure that your research is replicable is saying, well, you can bundle it all up, you can save the image, you can archive that, get a DOI for the whole package, and then other researchers maybe be able to fire that up again? Absolutely.
Indeed, in some of those, in some areas we're already doing some guidance, but we've got a long way a lot of extra stuff we could do.
Yeah. I mean, containers is an obvious thing, right? People are using containers on the Nectar cloud, but we don't really have any a system that says, you know, here's what you can do on the cloud. Here's some exemplars of how you can package your stuff up in a container, and you can store it here, and you can share it this way, and you can fire it up this way. I mean, that's something I think we really, you know, could be of quite some value, you know, to support our mission of enabling people to store and share and archive their research and make it more open, more fair. So yeah, I think we should definitely do some work along those lines. But it's just having, you know, we need more resources to do that, right? We just haven't got the resource to do that work at the moment.
I'm afraid I'm going to have to go because I've got another meeting starting in about 30 seconds. So.
Thanks, Wilfred.
No, thank
you. So, look, in general, I think it is now 2 o'clock, so we'll probably indeed people will have to move on to other meetings. First of all, I'd really like to thank Paul and Wilfred and Joe for the presentations. Thank you very much for the
don't thank me.
Preparing that and providing. Sorry, Wilfred.
Joe and Paul did all the prep. Don't thank me.
Okay. Well, big thanks to Paul and Joe especially then. So thanks for preparing those presentations and also that quite substantial documentation about the Nectar Cloud and how it works. There's probably more questions. I know I've still got a bunch of questions I'd like to ask. If anybody has any questions they'd like to ask, please put them into that Google. It's probably the best place to do it. Put it in that Google Doc. I can send it around after this meeting. You can add in extra questions because I'm sure there'll be some overlap between questions. So that will be one thing I'll send around. Please add any further questions in there and we can collect answers there too. Also, I'm a bit of a puzzle with Paul and Joe about how we might be able to, this was very much a theoretical exercise, providing you just with information about the Nectar Cloud. I think having a hands-on experience is also quite useful. So I also want to have a look with Paul and Joe what would be a good mechanism to make sure you get a chance to play with the Nectar Cloud and have a crack at it yourself. And maybe using those self-paced training modules or something along those lines. Yeah. But if you
there is a training workshop at the eResearch conference on the Monday morning, a Nectar 101 course, if you're interested in that as well.
Yeah. So I'll have a bit of a puzzle with Paul and Joe about what would be a good way to do that and how we can best do that. So watch this space.
Yeah.
Thank you all for your time, and then I look forward to seeing you sometime soon.